determine which ordered triple is a solution to the linear system. We have the ordered triples -4, 3, 3, and 1, -2, -2, and our linear system here. And I'll read these out as I substitute in those numbers, because what we need to do is find out, do these three numbers satisfy each of the three equations? So we substitute -4 for x. In the first equation, -4 minus 3 times, we substitute 3 for y, plus 4 times, we substitute 3 for z. And we want to know, does that equal -1? Well, this is -4. -3 times 3 is -9, and 4 times 3 is 12. When we add those together, they do equal -1. Now we substitute the same ordered triple into the second equation. 2 times -4 plus y, which is 3, minus 3 times z, and z is equal to 3, and we want to know, does that equal 6? 2 times -4 is -8, plus the 3. -3 times 3 is -9, and that actually equals -14, which means that it does not equal 6. So that tells us, actually at that point, that the ordered triple -4, 3, 3 will not satisfy this system of equations. Which means we don't have to show that it does or doesn't work for the third one, but let's just do that. We substitute in -4 for x, minus y, which is 3, plus z, which is 3. We want to know, does that equal +1? And of course, -4 minus 3 is -7. -7 plus 3 is -4, and it also does not work. So now, let's do that same exercise over here, substituting in this point of 1, -2, 2. So let's draw a line so that we don't get interfered. So we substitute 1 for x. 1 minus 3 times y, and y is -2, plus 4 times z, and z is -2. And we want to know, does that equal -1? Well, we have 1, and then a -3 times a -2 is a +6. 4 times -2 is a -8. 1 plus 6 is 7, minus 8 does equal -1. So that checks in the first equation. Now we substitute into the second equation, so we have 2 times x, which would be 2 times 1, plus y, which would be plus a -2, minus 3 times z, and z is -2. We want to know, does that equal 6? 2 times 1 is 2, plus the -2 is the same as subtracting 2. -3 times -2 is +6, and in fact that does equal 6, so the point or the ordered triple 1, -2, -2 checks in the second equation. For the third equation, we want x, which is 1, minus y, and y is -2, plus z, and z is -2. And we want to know, does that equal +1? We have 1 minus a -2. When you subtract a negative, it's the same as adding a positive, so it's 1 plus 2. And adding a negative is the same as subtracting a positive. And so we'll see that that does, in fact, equal 1. And it checks in all three equations. And so the ordered triple, 1, -2, -2, is a solution to that linear system.